roots of the polynomial. So first of all, what is the definition for that? If p of x is belongs to f of x, p of x belongs to f of x, then an element a lying in some extension field f is called the root of p of x. Root of p of x if p of a equal to 0. So root of the poly. So rootனா என்னன்னா ஒரு polynomial, then ஒரு element lying in the some extension field, then element is called the root அப்படின்னு சொல்லுவோம்னா, and element a is called the root of that root னு சொல்றோம்னா, that is satisfy that polynomial அர்த்தம். That is the p of a equal to 0 னா, that is called the root. For example, f equal to field is q, set of rational number, p of x equal to x square minus 2, which is belongs to q of x, that is f of x. Then a equal to root 2, which is belongs to r, that is the extension field, is a root, that is the a equal to root 2 is a root na solrana, root 2 satisfy the p of x. So here obviously root 2 square minus 2, that is 2 minus 2 equal to 0. Abna the a என்றது is the root of this polynomial. The same way a equal to minus root 2 is belongs to r is the extension field of q. So is also root because of minus root 2 whole square minus 2, that is 2 minus 2 equal to 0. So root 2 and minus root 2 both are lie in the extension field q of root 2 of q. So therefore this is the root. And polynomial division in the extension field. So the p of x belongs to f of x. P of x belongs to capital F of x if k is an extension of f. Then for any element b belongs to k, okay, k is an extension of f. For any element b belongs to k, p of x equal to x minus b into q of x plus p of b. P of x equal to, we can express x minus b into q of x plus p of b ன்னு எழுதலாம். So then where q of x belongs to k of x and degree of q of x equal to degree of p of x minus 1, degree of p of x minus 1, ஏன்னா ஒன்று வந்து linear factor product பண்ணிட்டோம். For example பார்த்தீங்கன்னா f equal to q and p of x equal to x cube minus 2x plus 1, which is belongs to q of x. K equal to r, that is the extension field, r is the extension field of q. Take b equal to 1, போட்டீங்கன்னா here 0, 1 is the 1 cube minus 2 into 1 plus 1, so it's become the 0. So p of 1 என்றது 0 ஆகிறதுனால by the polynomial division என்ன சொல்லுதுன்னா, this is equivalent to x minus 1 into x square plus x minus 1, that is the q of x. This is look like the quotient after dividing by the x minus 1. So the q of x equal to x square plus x minus 1, which is belongs to r of x, and the degree of q of x equal to 2, that is 3 minus 1, degree of p of x minus 1. So this is the division algorithm for that polynomial ring like this. Give the factor theorem, another one, that is a is belongs to k is the root of p of x, is the root of p of x belongs to f of x. K is an extension field of f. Then that k is the root of p of x. Then in k of x, then in k of x, x minus a divides p of x. X minus a completely divides p of x. That means remainder is 0 nu artham. So same example, 1 is the root of this one. Abna x minus 1 divides x cube minus 2x plus 1. That is called the factor theorem. And another definition, root of multiplicity m. Root of multiplicity m. A belongs to k is the root of multiplicity m. Root of multiplicity m. Or p of x belongs to f of x. That means x minus a whole power m divides p of x. That is, a is repeated m times nartham. Okay, when you solve the polynomial p of x nuடைய root வந்து a வந்து m times இருக்கு அப்படின்னு அர்த்தம். That is, x minus a whole power m divides p of x. Various x minus a whole power m plus 1 doesn't divide p of x. X minus a whole power m plus 1 doesn't divide p of x. For example, பார்த்தீங்கன்னா p of x equal to like this, இது மாதிரி எடுத்துக்கிட்டீங்கன்னா 1 is a root of multiplicity 3, ஏன்னா x minus 1 whole cube வந்திருக்கிறதுனால. minus 2ன்றது multiplicity 1 தான், ஆனால் 1ன்றது multiplicity of 3. So minus 2 root of multiplicity 1, that is a simple root னு சொல்லுவோம். ஸோ இது எல்லாமே நமக்கு தெரிஞ்ச விஷயம். பட் நாம் என்ன பண்ணுறோம், இந்த ஃபீல்ட் ஆஃப் எக்ஸ்டென்ஷன் ஃபீல்டில் அதை டிஃபைன் பண்ணுறோம். ஓகே, தட் இஸ் ஐடியா. ஸோ த மினிமம் நம்பர் ஆஃப் ரூட்ஸ், எ பாலினாமியல் ஆஃப் டிகிரி n ஓவர் எ ஃபீல்டு, எ பாலினாமியல் ஆஃப் டிகிரி n ஓவர் எ ஃபீல்டு கேன் ஹாவ் அட்மோஸ்ட் n root, can have at most n roots in any extension field, counting multiplicities. இது நமக்கு தெரிஞ்ச விஷயம் தான். பட் எக்ஸ்பிரஸ் இன் டெர்ம்ஸ் ஆஃப் என்னது, ஒரு எக்ஸ்டென்ஷன் ஃபீல்டில் ஒரு ஃபீல்டில் எக்ஸ்பிரஸ் பண்ணுறோம், அவ்வளோதான். ஒரு பாலினாமியல் ஆஃப் டிகிரி n இருந்ததுன்னா அதுக்கு அதிகபட்சம் n ரூட் இருக்கும், அட்மோஸ்ட் n ரூட். ஓகேவா, தட் இஸ் in any extension field இங்கே கொடுத்துருக்காங்க. x square plus 1 என்றது belongs to r of x. as degree என்னது, இது 2. பட் இதுக்கு ரூட் என்ன வரும், no root in r. இதுக்கு ரூட் வரலாம் காம்ப்ளெக்ஸில் இருக்கும். அதனால தான் இங்கே அட்மோஸ்ட்ன்ற வார்த்தையை யூஸ் பண்ணுறது. அட்மோஸ்ட் n ரூட், அதிகபட்சம் n கம்மியாக இருக்கலாம். ஸோ இதுக்கு வந்து மேக்ஸிமம் வந்து 2 ரூட்டு. இங்கே வந்து 2 ரூட்டுமே இதில் இல்லை, ரியல் நம்பராக இல்லை, காம்ப்ளெக்ஸ் நம்பராக தான் இருக்குது. அப்படின்னா நோ ரூட் இன் ஆர். ஓகேவா, தட் இஸ் த அனாலிசிஸ். அண்ட் இன் சி, இன் காம்ப்ளெக்ஸ் நம்பரில் பார்த்தீங்கன்னா இட் ஹாஸ் எக்ஸாக்ட்லி 2 ரூட், i and minus i. இதுக்கு 3 ரூட் இருக்குமான்னு கேட்டிங்கன்னா எந்த காலத்துலையும் இருக்காது. ஸோ மேக்ஸிமம் 2 ரூட்டு தான். அதே மாதிரி x square minus 2x plus 1, x minus 1 whole square. Okay, x minus 1 whole square, that is belongs to q of x. அப்படின்னா as 1 root, இதுக்கு எத்தனை ரூட் இருக்குது, ஒரு ரூட் இருக்குது. ஆனால் மல்டிப்ளிசிட்டி வந்து 2, அது that is repeated 2 times. Okay, so the same way, existence of root in finite extension. Existence of root in finite extension, p of x is a polynomial in f of x of degree n greater than equal to 1 and is irreducible over f, then there is an extension e of f, such that degree of e over f equal to n, in which p of x has a root. So this is the very important one, existence of root in finite extension. So what is the meaning? The p of x is a polynomial in f of x of degree n greater than or equal to 1. Okay, so the linear polynomial adukku mele irukano and is irreducible over f. அப்படி இருந்ததுன்னா then there is an extension for the field f, there is an extension e of f such that degree of e over f equal to n இருக்கும். Degree of e over f equal to n, in which p of x has a root, in which p of x has a root. That is a very important theorem result. For example, f equal to q field, p of x equal to x square minus 2 belongs to q of x. p of x is irreducible over q, no rational root idukku, rational root illa, so p of x is irreducible over q. E equal to, that is q of root 2. What is the q of root 2? Is the extension field. Okay, well, this is the extension field. Q of root 2 is a plus b root 2, the collection of a plus b root 2. Okay, well, root 2 is irrational number. A comma b belongs to q. So this is q of root 2. Now degree of e over f என்ன சொல்லுது அப்படினு பாத்தீங்கன்னா, degree of e over f என்றது 2. That means degree of p of x, degree of p of x என்றது 2. Okay, well, root 2 belongs to e என்றது is a root of p of x, in which p of x has a root எங்க அந்த extension field ல. So அதனால தான் root 2 belongs to e is a root of p of x. This is the example for this theorem. Okay, so the e is isomorphic to f of x by p of x generated by p of x. So இதனுடைய collection எப்படி இருக்குன்னா, x plus p of x is a root of p of x, x plus p of x is a root of p of x in e, in e. This is also some important idea. Okay. The next corollary to the theorem, that is finite extension containing a root, finite extension containing a root. F of x belongs to capital F of x. F of x belongs to capital F of x. Capital F of x is the field. Then there is a finite extension E of f, in which f of x has a root, in which f of x has a root. Moreover, degree of e over f less than or equal to degree of f of x. This is the finite extension containing a root. This is also very important. எல்லாத்தையும் கொஞ்சம் memorize பண்ணி மைண்ட்ல வெச்சுக்கணும். So இங்க பாத்தீங்கன்னா ஒரு f of x என்றது x cube minus 2, which is belongs to q of x like f of x மாதிரி. So இத factorize பண்ணீங்கன்னா என்ன எப்படி factorize பண்ணலாம்? x minus cube root of 2 into x square minus plus cube root of 2x plus cube root of 4 plus cube root of 4. So இங்க extension field நான் என்ன எடுக்கலாம்? q of cube root of 2 எடுக்கலாம். And degree of e over f என்ன? Degree of e over f is equal to 3, because of here the degree of the f of x, x cube minus 2, that is degree of f of x. The cube root of 2 obviously belongs to e. Okay, degree of cube root of 2 belongs to e. E என்றது q of cube root of 2 is a root of f of x, is a root of f of x. So இங்க degree of e over f என்றது less than or equal to degree of f of x. That means maybe 3 இருக்கலாம், 3 விட கம்மியா கூட இருக்கலாம். Okay, that is the theorem. Okay. The root existence, not all polynomial have a root in their base field. We can construct the larger field containing the root, that is the extension field. Find it for a degree n polynomial, we can find an extension of degree less than or equal to n containing a root, that is a finite extension. Okay. Irreducible case for irreducible polynomial, an extension, the extension degree equal to polynomial degree, extension degree equal to polynomial degree. Multiplicity inradhu roots can appear with higher multiplicity but still count toward the degree bound, toward degree bound. And the next topic is the existence of the splitting field. Existence of extension with old root, that is f of x belongs to f of x be a degree less than n greater than equal to 1, and there is an extension e of f of degree at most n factorial, at most n factorial, in which f of x has n root, in which f of x has n root, and so a full complement of the roots. Okay, that is there is an extension e of f of degree at most n factorial in which f of x has n root. ஏன்னா f of x degree வந்து n greater than equal to 1. அந்த பாலினாமியலுக்கு வந்து அட்மோஸ்ட் வந்து n root இருக்கும். அது வந்து எங்க இருக்குன்னா the extension fieldல இருக்கு. ஸோ இங்கே பேஸ் பார்த்தீங்கன்னா n equal to 1ன்னு வச்சிங்கன்னா e equal to fன்னு வந்துடும். That is degree of, that is the idea, that is a irreducible factor கண்டுபிடிக்கணும், factor p of x of f of x, and e equal to f of alpha, alpha is the root of p of x, degree of k over f என்றது less than or equal to n. In k of x ல f of x equal to like this, இது மாதிரி ஃபேக்டர் பண்ணி எடுக்கலாம், ஏன்னா alpha is the rootன்றதுனால. இப்போ degree of g of x equal to n minus 1 ஆகிடும், ஏன்னா ஒன்று குறைஞ்சிடும். g of x is splitting field. By induction, g of x is splitting field e over k, e over k, that is degree of e over k less than or equal to n minus 1 factorial. By the induction we can assume like that. So degree of e over f கண்டுபிடிச்சிங்கன்னா degree of e over k, degree of k over f, so n into n minus 1 factorial, that is less than or equal to n factorial வரும். That is the proof னுடைய ஒரு structure அது. That is a very important theorem. So இங்கே f of x equal to once again the same polynomial x cube minus 2 which is belongs to q of x. First extension பார்த்தீங்கன்னா q of cube root of 2. நமக்கு ஆல்ரெடி நம்ம லாஸ்ட் கிளாஸ் பார்த்தோம், டிகிரி ஆஃப் q of cube root of 2 over qன்றது is 3. over q of cube root of 2 f of xன்றதை எப்படி எழுதலாம்னா factorize பண்ணி x minus cube root of 2 x square plus cube root of 2x plus cube root of 4 னு எழுதலாம். இப்போ the quadraticன்றது as a root cube root of 2 into omega cube root of 2 into omega square, omegaன்றது e power 2 pi I by 3. ஸோ இது ரெண்டும் இந்த quadraticனுடைய root. And the splitting field என்ன சொல்லுதுன்னா the q of cube root of 2 omega with q of cube root of 2 comma omega over q is 6, over q is 6, 6 is nothing but the 3 factorial, 3 factorial is 6, that is the splitting field. Okay, the maximum n factorial. Now come to the point, what is the splitting field? f of x belongs to f of x. A finite extension e of f, the ஒரு finite extension e of f is said to be splitting field. Finite extension field is said to be splitting field of f for f of x. எதுக்கு f of x க்கு, அந்த பாலினாமியலுக்கு splitting field of f over f அப்படின்னு நாம் சொல்லணும்னா, if over e, that is in e of x, that is the finite extension. If over e but not over any proper subfield of e, but not over any proper subfield of e, f of x can be factored as a product of linear factors. F of x can be factored as a product of linear factor. then that is called the splitting field. For example பார்த்தீங்கன்னா x square plus 1 c ன்றது over c f of x எப்படி எழுதலாம்னா x minus i into x plus i ன்னு எழுதலாமா x square plus 1 ன்றதுனால. So the no proper subfield of c containing or can contain the both I and minus I. That is a very important point. No proper subfield of C containing or can contain both I and minus I. Then C is called, then C is a splitting field of, C is splitting field of x square plus 1 over R. Then C is splitting field of x square plus 1 over R. So this is a very simple example. What do you mean the splitting field? The same way another example, f of x equal to x cube minus 2 which is belongs to q of x. So what are the root? இப்போ தான் நிறைய பார்த்தோம், 2-3 தடவை பார்த்தோம். Cube root of 2, cube root of 2 omega, cube root of 2 omega square. This splitting field in a q of cube root of 2 comma omega. So proper subfield like q of cube root of 2 don't contain the all root. Okay, don't contain the all the roots. So that is the another splitting field. The next polynomial ring isomorphism, that is the tau from f to f dash is an isomorphism. Tau from f dash is an isomorphism. Then tau star என்றதுனானா f of x to f dash of t. F of x to f dash of t. How to define this one அப்படின்னு பார்த்தீங்கன்னா, for every polynomial in f of x, go to polynomial in f dash of t. That is the definition, the tau star. So is an isomorphism. Actually நாம் என்ன எடுத்துக்கோம், tau from f to f dash is an isomorphism. Tau star from f of x to f dash of t is an isomorphism. What are the property now? With the property that a tau star equal to a dash, illa alpha tau star equal to alpha dash for every a belongs to f. For every a belongs to f. Okay, well, this is an isomorphism with the property a tau star equal to a dash for every a belongs to f. The next பார்த்தீங்கன்னா quotient ring isomorphism. அது என்ன quotient ring isomorphism? There is an isomorphism tau double star of f of x by f of x, that is generated by the f of x, the polynomial, on to f dash of t divided by f dash of t. இங்க வந்து just f of x to f dash of t. இங்க என்ன இருக்கு, ஒரு quotient space இருக்கு. With the property that, என்ன property, that is a for every a belongs to f, a tau double star equal to a dash. That means and x plus f of x into a என்றது எப்படி இருக்கும், x plus f of x இருக்கும், because of the other quotient space என்றதுனால. X plus f of x into tau double star equal to t plus f dash of t. This is the quotient ring isomorphism. Here f equal to q, f dash is also q. F of x என்றது x square minus 2, f dash of t என்றது t square minus 2. F of x by x square minus 2 is isomorphism to q of root 2. That is the idea. And f dash of t divided by t square minus 2 isomorphic to q of root 2. So the isomorphism sends x plus x square minus 2 to t plus t square minus 2. So both represent the root 2 in their respective field. In their respective field root 2. And isomorphism simple extension. If a p of x is irreducible, in f of x, v is a root of p of x, p of x என்றது irreducible in f of x, then f of v is isomorphic to f dash of w. W என்றது என்னன்னா is a root of p dash of t. W is a root of p dash of t. That is also a simple important one. F of v is isomorphic to f dash of w, and f dash of w that is the root of p dash of t. Moreover, this isomorphism sigma can be chosen so that v sigma equal to omega, v sigma equal to w, alpha sigma equal to alpha dash, alpha sigma equal to alpha dash for every alpha belongs to f, for every alpha belongs to f. Okay, so therefore f equal to q. Okay, f equal to q, and p of x equal to x square plus x plus 1. V equal to, that is omega illa w, v equal to w, that is a primitive cube root of unity, primitive cube root of unity, omega under. So f dash equal to q. Once again, the p dash of t, what is it? Is the t square plus t plus 1. Here omega equal to omega square. அவங்க என்ன சொல்றாங்கன்னா sigma, that is this isomorphism sigma, that is f dash of omega to f of v isomorphism to f dash of something, so that sigma ன்றது q of omega, that is f of v, like this, on to q of omega, so that is the f dash of omega, f dash of omega, that is omega sigma illa w sigma equal to w square, a sigma equal to a for all a belongs to q, for all a belongs to q. So therefore q of omega equal to q of omega square as sets, but the isomorphism is non-trivial, isomorphism is not trivial, that is non-trivial. That is the example for that theorem. Theorem is very important. And another one, that is the conjugate isomorphic, conjugates are isomorphic. P of x into the f of x is irreducible. A, b into the are two roots of p of x. F of a is isomorphic to f of b by any isomorphism which takes a onto b and which leaves every element of f fixed. Every element of f is fixed. Okay, there is a corollary to the above theorem. P of x into the x cube minus 2 belongs to q of x. Roots பார்த்தீங்கன்னா இதுக்கு இதுதான் roots. நேரம் மெமரியாக இருக்கணும் இது உங்களுக்கு. Q of cube root of 2 is isomorphic to q of cube root of 2 omega. This is isomorphic q of cube root of 2 omega square. So the isomorphism sent cube root of 2 to cube root of omega and fixes q, and fixes q. And uniqueness of the splitting field. Any splitting fields E and E dash of the polynomial f of x belongs to f of x. Splitting field, rendu splitting fields, f dash of t belongs to f dash of t respectively. E என்றது splitting field of the polynomial, that is f of x belongs to f of x, and E dash is a splitting field of the polynomial f dash of t belongs to f dash of t. Both are isomorphic by an isomorphism pi with the property alpha pi equal to alpha dash, a pi equal to a dash for every alpha belongs to f. That means in particular any two splitting field of the same polynomial over the given field f are isomorphic by an isomorphism leaving every element of f fixed. Every element of f is fixed. Okay, f of x equal to, suppose once again the same example, q of x நாம் எடுக்கிறோம்னா, one splitting field q of cube root of 2 comma omega is the subset of C, and another one, the q of cube root of comma omega is the subset of some other algebraically closed field. So theorem என்ன சொல்லுதுன்னா, these are isomorphic, these are isomorphic as field over q, field over q. அதே மாதிரி every polynomial has a splitting field. All splitting fields of the same polynomial are isomorphic, and the degree of E over F is bounded by n factorial, that is less than or equal to n factorial for splitting field of degree n polynomial, and isomorphism between the base field extends the splitting field. base field to splitting field. These results form a foundation for the Galois theory, where we study the automorphism of the splitting field that fix the base field, The example for splitting field and extension degree. The first of all, the quadratic polynomial. So f என்றது any field. P of x equal to x square plus alpha x plus beta. Alpha comma beta belongs to f. Be in f of x. எது P of x in f of x. f என்றது any field. அந்த coefficient எல்லாம் belongs to f. K என்றது any extension of f. In which P of x as a root. And the extension P of x as a root. Then the element b equal to minus alpha minus a also in k. So actually k என்றது ஒரு extension field of f in which P of x as a root. P of x belongs to f of x. The P of x as a root in the extension field of f. அப்படி இருந்ததுன்னா then the element b equal to minus alpha minus a. என்றது root a. ஓகேவா? So minus alpha minus a என்றது alphaன்றது coefficient of x இங்க அந்த P of x ல. Minus alpha minus a is also in k, also root of P of x, that is the problem. So இங்க பாத்தீங்கன்னா P of b ன்றது I will try to find the P of b. P of x ன்றது what is the P of x? That is x square plus alpha x plus beta. அப்புறம் P of b கண்டுபிடிச்சோம்னா P of b னா என்ன? That is equivalent to P of minus alpha minus a. கரெக்டா? அப்புறம் மைனஸ் x க்கு பதிலாக minus alpha minus a whole square plus alpha into minus alpha minus a plus beta. இதை சிம்பிளி பண்ண a plus b whole square ஃபார்முலா, ஏன்னா ரெண்டுமே மைனஸாக இருக்கிறதுனால alpha square plus 2 alpha a plus a square minus alpha square minus alpha a plus beta. இப்போ என்ன பண்ணலாம்? இந்த ஆல்ஃபா ஸ்கொயர் கேன்சல் ஆகிடும். அப்படின்னா இது மைனஸ் ஆல்ஃபா ஏ இருக்குது, ஏ ஸ்கொயர் இருக்குது. ஓகே, அண்ட் 2 alpha a minus alpha a is become the alpha a. The a square அப்படியே வந்துடும். ஓகே, அண்ட் பீட்டா அப்படியே வந்துடும். இது ஆல்ஃபா a அண்ட் a ஸ்கொயர் ப்ளஸ் பீட்டா. ஏன்றதுனது P of x னுடைய ரூட். ஏன்றது P of x னுடைய ரூட். அப்படின்னா ஏன்றது P of x னுடைய ரூட்னா இதை கரெக்ட் ஆர்டரில் எழுதிருக்கலாம். இதோட் a ஸ்கொயர் ப்ளஸ் ஆல்ஃபா a ப்ளஸ் பீட்டா. ஏன்றது P of x னுடைய ரூட்னா இது ஆட்டோமேட்டிக்காக என்ன ஆகிடும்? 0 ஆகிடும். இது 0னா என்ன அர்த்தம்? P of b கொண்டு 0, அதாவது P of மைனஸ் ஆல்ஃபா மைனஸ் ஏன்றது 0. அப்படின்னா P of b கொண்டு 0னா இந்த bன்றது is a root of P of x. இந்த கேஸ் b equal to a ன்னு எடுத்துக்கிறோம்னு வச்சுக்கோ. b equal to a னா மைனஸ் ஆல்ஃபா மைனஸ் a, ஆல்ஃபா மைனஸ் ஆல்ஃபா in the case b equal to a, the minus alpha minus a equal to a, P of x என்ன ஆகும்னா that is x minus a whole square. So both roots are in k. b is not equal to a னா both distinct roots are in k. இதனுடைய conclusion என்ன? P of x can be split by an extension of degree 2 of f. That is when you apply the theorem 5.3.2 that gives the bound degree of e over f is less than or equal to 2 factorial, that is equal to 2. And another example பார்த்தீங்கன்னா cubic polynomial x cube minus 2 over q, f equal to q, f of x equal to x cube minus 2. In C, the three roots are, what are that? Cube root of 2 and omega cube root of 2 and omega square cube root of 2. The cube root of 2, real cube root of 2. Omega cube root of 2, omega என்றது minus 1 plus root 3i divided by 2. எல்லாருக்கும் தெரியணும். என்ன omega square என்றது minus 1 minus root 3i divided by 2. Minus 1 minus root 3i divided by 2. That is called that omega square. So f of cube root of 2 equal to, that is the q of cube root of 2. Cannot split x cube minus 2 because as a subfield of R, it cannot contain the complex root. It cannot contain the complex root omega cube root of 2, omega square cube root of 2. So x cube minus 2 is irreducible over q. Irreducible over q. We can apply the Eisenstein criterion with p equal to 2. And the last 2 இருக்கிறதுனால prime number. என்ன Eisenstein criterion? p என்றது equal to 2 divides 2, but p square 2 square doesn't divide 2. This is the constant. And p equal to 2 divides all other coefficients except the highest power. Highest power என்றது x cube. x cube நோட coefficient 1. p equal to 2 doesn't divide 1, highest coefficient. All other coefficient p equal to 2 divide பண்ணணும். That is called the Eisenstein criterion. அப்படி இருந்ததுன்னா that is called the irreducible over q. So this is the irreducible over q. That is a very simple. இதெல்லாம் மறக்கக்கூடிய விஷயம் இல்லை. இதெல்லாம் மறக்காம ஞாபகம் வச்சுக்க வேண்டிய விஷயம். The q of cube root of 2 over q என்றது, that is, what is the degree? That is 3. Since the minimal polynomial is x cube minus 2, that is satisfying the cube root of 2. So therefore, how to find out the degree of E over Q for the splitting field E? For the splitting field E. So what is the theorem? E over Q is the less than or equal to 3 factorial. That is equal to 6. Since Q of cube root of 2 is the subset of E splitting field, Q of cube root of 2 over Q equal to 3. By the Tower theorem, that is 3 divides E, degree of U over Q. Degree of U over Q. So அப்படினா என்ன வரும்? Since E is a properly contains Q of cube root of 2, so degree of as it contains the complex roots, the only possibility for the degree of U over Q, the degree of U over Q should be greater than 3. So degree of U over Q only possibility வந்து 6. ஏன்னா 4 வராது, 5 வராது. ஏன்னா அதெல்லாம் டிவைட் பண்ணாது. எது டிவைட் பண்ணாது? 3ன்றது டிவைட் பண்ணாது. So the only possibility is 6. So alternative construction பார்த்தீங்கன்னா, that is the f1 equal to q of cube root of 2, f1 over q என்றது 3 over f1 adjoint, we need adjoint omega, where omega னுடைய property என்ன? Omega square plus omega plus 1 equal to 0. 1 plus omega square equal to 0. This is the cube root of unity என்றதுனால. அப்படினா the polynomial x square plus x plus 1 என்றது is irreducible over q. Remains irreducible over f1. So actually x square plus x plus 1 has a root omega square which are complex. f1 என்றது subset of R, so that is irreducible over f1. So degree of u over q, degree of u over f1 over q, that is 2 into 3 equal to 6. இது நாம் already பார்த்தது தான். The last one I thought quartic polynomial, that is the 4th degree polynomial. First 2nd degree பார்த்தோம், அப்புறம் cubic பார்த்தோம். இது 4th degree polynomial. That is quartic சொல்லுவாங்க. Quartic polynomial x power 4 plus x square plus 1 over q. இந்த எக்ஸாம்பிள் பார்த்தீங்கன்னா f equal to q, field வந்து rest of rational number, f of x equal to belongs to f of x. நாம் என்ன ப்ரூவ் பண்ணா e equal to f of omega, e equal to f of omega, omegaன்றது -1 plus root 3i divided by 2 is a splitting field, that is the splitting field of f of x, splitting field of f of x. So what is f of x? X power 4 plus x square plus 1. So splitting field means this is factored, that is x square plus x plus 1, x square minus x plus 1. Okay, am I correct? So that is இது ரெண்டுத்தையும் மல்டிப்ளை பண்ணிங்கன்னா உங்களுக்கு என்ன கிடைக்கும்னா அந்த பாலினாமியல் கிடைச்சிரும். அப்படின்னா that is the x square plus x root of x square plus x plus 1 என்னன்னா ஒமேகா ஒமேகா ஸ்கொயர் 1 ஒமேகா சாரி ஒமேகா அண்ட் ஒமேகா ஸ்கொயர். x square minus x plus 1 உடைய ரூட் என்ன அப்படின்னு பார்த்தீங்கன்னா இந்த ஃபார்முலா அப்ளை பண்ணிங்கன்னா அந்த குவாட்ரடிக் ஃபார்முலா -1 plus or minus root 3i something வருது. அது -1 plus or minus root 3i divided by 2 ஒமேகான்றது இது 1 plus or minus root 3 by 2. So 1 plus root 3i என்றது minus omega square, 1 minus I root 3i divided என்றது minus omega. Correct? So all roots are in q of omega, all roots are in q of omega. So the four roots omega, omega square, minus omega square, all of them belongs to q of omega. So the minimality check பண்ணனும்னா omega is not a real, omega is not a real, and the polynomial as non-real roots, polynomialன்றது as non-real roots. So no proper subfield of q of omega can contain all roots. Proper subfield of q of omega can contain all the roots. So the minimal polynomial of omega is x square plus x plus 1, that q of omega over q is equal to 2. So E equal to q of omega is indeed the splitting field of x power 4 plus x square plus 1 over q with the degree of E over q equal to 2. So which is much smaller than the maximum possibility 4 factorial, that is 24. So therefore degree of this is the conclusion, degree of E over q less than or equal to 4 factorial, that is equivalent to 2, which is much smaller than the maximum possibility of the 4 factorial. Okay, this is a very important one. The 3 example me உங்களுக்கு எஸ்டின் bookல இருக்க example தான். Example 3, that is the f of omega is the splitting field of x power 4 plus x square plus 1 over the q, over q. Omega என்றது is the -1 plus or minus plus I root 3 divided by 2. So already நம்ம show பண்ணது, that is the splitting field the factorize பண்ணலாம், quadratic factor. இதுக்கு omega omega square minus omega omega square, these are the contained in the f of omega, all four roots. So we want to try to prove the f of omega is the splitting field. So all roots are in f of omega, and no proper subfield of f of omega contains all roots. So the minimal polynomial for the omega over q is this is, so f of omega over f equal to 2. So the only proper subfield are f itself. So possible and possible others are f doesn't contain any roots, they are complex. Any proper subfield k with f is subset of k, k is the subset of f of omega. So degree of k over f is equal to 1, that is k equal to f. So no proper subfield contains all roots. F of omega is the splitting field, indeed the splitting field. And another one, another problem, f equal to q, determine the degree of the splitting field of x power 4 plus 1, x power 6 plus 1, x power 4 minus 2, x power 5 minus 1, x power 6 plus x cube plus 1. So mostly இந்த ப்ராப்ளத்துக்குள்ள தான் கேட்பாங்க, டிஃப்ரெண்ட்டாக எதுவும் புதுசாலாம் கேட்க போகிறது கிடையாது. ஸோ x power 4 plus 1ன்றது roots are primitive 8th root of unity, that is e power pi I by 4, e power 3 pi I by 4, e power 5 pi I by 4, e power 7 pi I by 4, and splitting field is, that is zeta 8, q of zeta 8, and whereas zeta 8 equal to e power pi I by 4, e power pi I by 4, the minimal polynomial of the zeta 8 is the 8th cyclotomic polynomial, that is the pi 8 of x equal to x power 4 plus 1. So the degree of this one cyclotomic polynomial q of zeta 8 over q, that is the pi of 8. Pi of 8 how to find out that is the Euler pi function, that is I thought 2 cube, that is 2 cube into 1 minus 1 by 2, that is I thought 2 cube into 1 by 2, this is cancelled, that is 2, that is 2 square equal to 4. So எங்கெல்லாம் அந்த Euler pi function யூஸ் ஆகுது பாருங்க. So the degree of the splitting field கண்டுபிடிக்கிறதுக்கு நம்ம Euler pi function யூஸ் பண்ணலாம். But there is what is the root of unity. So degree of E over F equal to 4. Degree of E over F equal to 4. And the same way x power 6 plus 1, that is x power 6 plus 1 under the factorize பண்ணலாம். X square plus 1, x power 4 minus x square plus 1. The roots are பார்த்தீங்கன்னா இதுக்கு root வந்து I minus I, இதுக்கு root வந்து y equal to x square வச்சுட்டு y square minus y plus 1 equal to 0. இப்போ தான் கண்டுபிடிச்சோம் 1 plus or minus I root 3 divided by 2ன்றது. So x equal to கண்டுபிடிக்கும் போது plus or minus root of something வரும். ஓகேவா? ஸோ அதனுடைய ரூட்டு மொத்தம் r root வரும். So splitting field contains I and root 3i, so it contains root 3 and I. So the splitting field q of root 3 comma I. So we have the q of root 3 over q equal to 2. Q of root 3 comma I over q of root 3 equal to 2 because of x square plus 1 is reducible over q of root 3 என்றதனால. So degree of E over F என்றது என்ன பண்ணலாம்னா this one to this one, that is 2 into 2 equal to 4. 2 into 2 equal to 4. Okay, and x power 4 minus 2, x power 4 minus 2 now that is the fourth root of roots are fourth root of 2 and I fourth root of 2 minus fourth root of 2 minus I fourth root of 2. இதனுடைய splitting field பார்த்தீங்கன்னா q of fourth root of 2 comma I and q of fourth root of 2 over q ன்றது that is 4 because of x power 4 minus 2 is reducible by Eisenstein. So therefore and q of fourth root of 2 comma I over q of q fourth root of 2 equal to 2 because of x square plus 1 is reducible over q of fourth root of 2 is the subset of R. So the degree of E over F when you apply this one over this one, that is 4 into 2, that is equal to 8, degree of E over F. The same way x power 5 minus 1, x power minus 1 என்றது இது மாதிரி factorize பண்ணலாம். So x minus 1 into this is obviously this is irreducible. Okay, so splitting field q of zeta 5 என்றது e power 2 pi I by 5, 2 pi I by 5. So the minimal polynomial of zeta 5 is the fifth cyclotomic polynomial. Fifth cyclotomic polynomial என்றது this is the pi of x. So இதனுடைய டிகிரி நாம ரொம்ப ஈஸியாக கண்டுபிடிக்கலாம், that is pi of 5. Pi of 5 என்றது 5 into 1 minus 1 by 5, that is equal to 5 minus 1 4, that is equal to 4. So degree of E over F என்றது is equivalent to 4. Degree of E over F என்றது is equal to 4. And x power 6 plus x cube plus 1, this is equal to x power 9 minus 1 உடைய one of the அதை factorize பண்ணீங்கன்னா x cube minus 1 into the x power 6 plus x cube plus 1 வரும். So the root of x power 6 plus x cube plus 1 are the primitive ninth root of unity. Correct? இதான் இப்படி factorize பண்ணது. This is the primitive ninth root of unity except the cube root of unity. அதில் வந்து except cube root of unity accept பண்ணணும். கரெக்டா? So the primitive ninth root of unity என்றது the polynomial is the ninth cyclotomic polynomial. Ninth cyclotomic polynomial அப்படின்னா pi 9 of x ன்னு எழுதலாம். இதனுடைய splitting field is pi of zeta 9. அந்த notation வந்து zeta 9 என்றது e power 2 pi by 9. அப்படின்னா இதனுடைய டிகிரி கண்டுபிடிக்கணும் pi of 9 நீங்க கண்டுபிடிச்சா போதும். ஓகேவா? that is equal to 6. So 9 என்றது 3 square, that is 3 square into 1 minus 1 by 3. So that is equal to 2 by 3, that is ஒரு 3 அடிச்சிட்டிங்கன்னா 6. So இது 6 னா degree of u over f equal to 6. Okay, so that is the idea. இதே மாதிரி தான் அந்த first problem போட்ட மாதிரி தான் இது, very first problem. ஸோ இந்த 4 ப்ராப்ளம்னு நினைக்கிறேன், 4 ப்ராப்ளமும் நல்லா தரவு பண்ணுங்கள், ஆல்ரெடி பார்த்த ப்ராப்ளம் தரவு பண்ணுங்கள். ஓகே, தட் இஸ் அ வெரி இம்பார்ட்டண்ட், டெஃபினட்டாக கேட்கறதுக்கு நிறைய வாய்ப்புகள் இருக்குது. நாட் ஓன்லி டிஆர்பி அண்ட் CSIR net சரி. P is a prime number, then the splitting field over Q of x power p minus 1 is of degree p minus 1. P ன்றது prime number-ஆ இருந்ததுன்னா splitting field over Q of x power p minus 1 is of degree p minus 1. இதை மெமரைஸ் பண்ணலாம், அப்ளை பண்ணலாம். அப்படின்னா x power p minus 1 ன்றது x minus 1 into x power p minus 1. இது cyclotomic polynomial. This is the cyclotomic polynomial. So that p ன்றது prime. What is that? இப்போ தான் பார்த்துட்டு இருக்கோம். Pi p of x ன்னு எழுதலாம். That is the pth, the second factor is the pth cyclotomic polynomial. Our pi p of x is irreducible over Q. Our pi p of this is the classical result, that is the Eisenhower criterion. apply பண்ணும் x equal to y plus 1 ன்னு போட்டீங்கன்னா இதெல்லாம் நமக்கு தேவையில்லை. So just try to understand, அதாவது without using the Eisenhower criterion எப்படி how to find out the irreducibility அப்படின்றதுக்கு தான் இது. ஜஸ்ட் இது மாதிரி சேஞ்ச் பண்ணி x equal to p plus 1. ஓகே, x equal to p plus 1 ன்னு போட்டேன்னா ஓகே, this is the splitting field of is pi of q of zeta. We get the irreducible proof பண்ணலாம். x equal to y plus 1 ன்னு போட்டால் irreducibility proof பண்ணலாம். ஒரு ப்ராப்ளம் ஒன்று இருக்குது, அது பின்னாடி பார்ப்போம். And the splitting field is pi of zeta p. So actually என்ன வரும் அதுக்கு, that is the pi of p is the degree இல்லையா, டிகிரி கண்டுபிடிக்கிறேன்னா pi of p. pi of p ன்றது prime number இருந்தால் p minus 1. that is the idea. okay, so இதான் summary. இதெல்லாம் மெமரைஸ் பண்ணிங்கன்னா கூட you get the mark. okay, that is the x power 4 plus 1. what is the splitting field degree? that is the what is the y reason? that is the 8th cyclotomic polynomial, that is pi of 8 and equal to 4. that is adanala these are some great. and n greater than 1, the splitting field of x power n minus 1, the splitting field of x power n minus 1 over q is of degree pi of n, is of degree pi of n, where pi is the Euler pi function. இதை தான் இவ்வளோ நேரம் அப்ளை பண்ணிட்டு இருந்தோம். இந்த படித்ததை அப்ளை பண்ண ஸ்டார்ட் பண்ணிங்கன்னா that is very best. and another problem பார்த்தீங்கன்னா f equal to q, the necessary and sufficient condition on a and b so that the splitting field x cube plus ax plus b as degree exactly 3 over f, exactly 3 over f. so that is x cube plus ax plus b belongs to q of x, belongs to q of x, and f of x ன்றது is irreducible over q. f of x has rational root, f of x has rational root, then it factors as x minus r into g of x. g of x is a quadratic இல்லையா, g of x is irreducible over q, the splitting field has degree 2 over q. already g of x is reducible over q. if g of x is reducible over q ஆ இருந்ததுன்னா, irreducible ஆ இருந்தால் degree 2, reducible ஆ இருந்தால் splitting field is q itself, therefore degree வந்து 1 ஆயிடும். மொத்தம் வந்து for degree 3 f of x must be irreducible over q, f of x must be irreducible over q ஆ இருக்கும். so f of x is reducible over q, the roots of the RST, the splitting field q of RST, f of x irreducible cubic, that is q of r over q equal to 3, and discriminant பார்த்தீங்கன்னா r minus s whole square, r minus t whole square, s minus t whole square. Therefore the cubic x cube plus ax plus b, the discriminant பார்த்தீங்கன்னா that is b square minus 4ac, that is the minus 4a cube minus 27b square for the cubic. So that so necessary sufficient condition பார்த்தீங்கன்னா for the this is irreducible over q இருக்கணும் and square root of அந்த discrete minus 4a cube minus 27b cube belongs to q. This is the perfect square in q. Okay, for example x cube minus 3x plus 1 என்றது as a discriminant 4 into minus 4 into for the cubic இது discriminant cubic equation க்கு minus 4 into minus 3 whole cube minus 27 into 1 square, that is 81. That is root of 81 equal to 9. 9 belongs to q. The splitting field has degree 3. Okay, that is the idea. And x cube minus 2 as a discriminant minus 108. Either the root of minus 108 not belongs to q. So apna discriminant splitting field as degree 6. Splitting field as degree 6. Okay. And p be a prime number and let f equal to fp, the field of integers modulo p be a prime number and let f equal to fp, the field of integers modulo p, then there is an irreducible polynomial of degree 2 over f. Use this polynomial to construct the field with p square element, and any two irreducible polynomials of degree 2 over f lead to isomorphic field with p square element. Isomorphic field with p square element. The first of all, this is a very important result. The p is a prime number. F என்ற field வந்து that is the fp, the field of integer modulo p. Field of integer modulo p. Then there is a irreducible polynomial of degree 2. There is an irreducible polynomial of degree 2 over f. This is the first result. And another result, use this polynomial, that polynomial degree 2, to construct a field with p square element. That is the second result. And any two irreducible polynomial of degree 2 over f, that is lead to isomorphic fields with p square element. Result ஞாபகம் வச்சுக்கங்க, that is the best. And E is an extension of f. F of x belongs to f of x. Pi is an automorphism of E. And leaving every element of f fixed. Is fixed. Then pi must take a root of f of x. Take a root of f of x lying in E into the root of f of x in E. And another result, f of cube root of 2. Where f is the field of rational numbers, has no automorphism other than the identity automorphism. So, that is a counter example. So when you apply that, if the complex number alpha is the root of the polynomial p of x having the real coefficients, then alpha bar, the complex conjugate of the alpha, is also root of p of x. So எப்பவுமே 2 plus I மட்டும் ரூட்டாக இருக்காது, 2 minus I is also root. அதே மாதிரி m is an integer, which is not a perfect square. Alpha plus beta root m is the root of the polynomial p of x having the rational coefficients. So அதே மாதிரி rational root conjugate is also root ஆக இருக்கும், that is alpha minus b beta root m is also root of p of x. So இதெல்லாம் well known result, நம்ம ஃபெமிலியராகவே தெரியணும், பட் இங்கே அல்ஜிப்ராவில் படிக்கிறோம் அவ்வளோதான் ஃபீல்டெல்லாம். Okay. And f is the field of real numbers. Then pi is an automorphism of f. Then pi leaves every element of f is fixed. And the result konjam naam vechunga, that is important. And h is the real quaternions. The real quaternions, find all real quaternions t equal to a0 plus a1i, a2j, a3k, satisfying the t square equal to minus 1. For a t as in part A, that is can find the real quaternion. We can find the real quaternions S such that ST S inverse equal to I. This is one of the example idhula stop pannalam. So the 8x cube minus 6x minus 1 is reducible over q. இங்க பாருங்க இது 1 இது. So இதில் நாம் வந்து ஐசன்ஸ் கிரைட்டீரியன் அப்ளை பண்ண முடியாது, ரேஷனல் ரூட் தியரம் அப்ளை பண்ணலாம். வாட் இஸ் த ரேஷனல் ரூட் தியரம்? தட் இஸ் 1 உடைய ரூட் பார்த்தீங்கன்னா 1 உடைய ஃபேக்டர்ஸ் ஒன்லி ப்ளஸ் ஆர் மைனஸ் 1. இங்கே ஹையஸ்ட் கோஎஃபிஷியன்ட் 8 உடைய ஃபேக்டர் பார்த்தீங்கன்னா that is the plus or minus 1, plus or minus 2, plus or minus 4 and plus or minus 8. இது ரெண்டுத்தையும் டிவைட் பண்ணீங்கன்னா the rational root is of the form plus or 1 minus 1 divided by plus or minus 1, the plus or minus 1 divided by plus or minus 2, the plus or minus 1 by 2, plus or minus 1 divided by plus or minus 4, that is plus or minus 1 by 4, plus or minus 1 divided by plus or minus 1 by 8. So these are possible rational root. Suppose இதில் எதுவுமே ரூட் இல்லைன்னா no rational rootன்னு அர்த்தம். So for this problem no rational root. ஓகேவா, எல்லாமே செக் பண்ணீங்கன்னா, so the polynomial is cubic if it were the reducible over q. If it were reducible over q, it would have the linear factor that is contradicting the rational roots. So therefore it is irreducible. Suppose x cube minus 2, it's a very easy because of this is the prime number 2, அதனால் ஐசன் கிரைட்டீரியன் அப்ளை பண்ணலாம். இப்போ தான் பார்த்தோம், this is irreducible. ஐசன் கிரைட்டீரியன்றது, so the prime number divides the constant term, but the square of the prime number doesn't divide the constant term, and the prime number doesn't divide the highest power of the coefficient of highest power of the polynomial, and all other coefficients on the prime number divide பண்ணணும். That is the isolated criterion. அப்படி இருந்ததுன்னா that is called the irreducible. இதனுடைய irreducibility நம்ம செக் பண்ணுறதுக்கு, that is irreducible over q-னா இங்கே 1 வந்துருச்சு 1/7. அப்படின்னா that rational root theorem அப்ளை பண்ணலாம். 1, இதுவும் 1 தான். ஸோ அப்படின்னா 1 உடைய ஃபேக்டர் ஃபஸ்ட் இந்த கான்ஸ்டன்ட் டேர்ம் ப்ளஸ் ஆர் மைனஸ் 1. இங்கே ஹையஸ்ட் பவனுடைய கோஎஃபிஷியன்ட் இஸ் 1, அதுக்கும் plus or minus 1. Rational root தேர்வு என்ன சொல்லுதுன்னா 1 by 1, that is plus or minus 1 is a rational root இருக்கும். அப்படின்னா ரெண்டு தான், f of 1 f of minus 1 ரெண்டுமே 0 இல்லை அப்படின்னா no rational root, அப்படின்னா irreducible. This is the irreducible over Q. And 2 cos 2 pi by 7 satisfy the something. இது வெரிஃபை பண்ணி பாருங்க. that is cos 2 pi by 7ன்றது omega equal to e power 2 pi a by 7 எடுக்கலாம், because of omega power 7 equal to 1, omega not equal to 1. I leave it to this problem. Okay, I'll stop here.